Sorry, just looking at the chat. Yes, sorry. I was just waiting for others to join, so I hadn't started as yet. But good evening to everyone on the session. I hope you're all doing well and are having a good week so far. Welcome to our third collab session. Today we're looking at Learning Unit 3, Part 1. And I say Part 1 because we are splitting the Learning Unit up into two parts because that is how it is tested, examined as well, where you have the first half being ungrouped data, like you see up on the screen, where you have values that are listed out for you randomly. And then you also have the second half of the learning unit, which would be a table with information that looks like this. So for today, we are not going to look at this worksheet, the one that you see up on the screen, or well, the second half of the worksheet. That we will leave for next week. For today's session, we are looking at just this first page. So the learning unit is, as I said, broken up into two. This is something I discussed in a bit of detail in the first session for the semester. Remember, this also forms part of your assignment 2 and your exam, where this learning unit is going to be one of the questions where you have options. So you are either going to choose the section that is based on ungrouped data, or you're going to answer the question based on grouped data. So not both of them, just one of them. It will be the same in assignment 2 and the exam. In both the assignment 2 and your exam, you will have a choice. So you are essentially, when studying for your exam, not learning one of these sections. So most of the time, the more common section is the first one that we're going to be looking at today, just simply because it is something that you would have previously come across, whether it was in school mathematics that you had done it, or just the very basics of any math module that you've probably possibly done before, or you've generally definitely come across these values before, these calculations before. So it is very, very basic, these calculations. It is easier than the grouped data section for sure, because with the group data section, you have specific formulas that are used. It can get a bit complicated. In your exam, although there is a formula sheet, essentially you will still need to know what each variable in a formula represents. So it can get a bit much when having to study that section. And the easier one would be obviously this, because you're a bit familiar with it. Most of you should be a bit familiar with this. Even if it's just one or two calculations here that you're familiar with, you have definitely come across most of this before. So it is something that isn't intimidating. You haven't generally seen it previously. So hopefully this would be something that you are yes, definitely. Sorry, I was just reading the chat. Definitely also something you would have done previously in maths lit before, but also just in general maths. You would have definitely in your normal well, previously standard grade, higher grade maths, you would have definitely seen it in pure maths before. And it entails two parts where you are looking at a graphical approach to your ungrouped data, and then also this mathematical approach. So you are required to draw up in certain instances. Most of the time it is in both the exam and the assignment, where you will be given at least one graphical approach, meaning you'll be asked to draw up a diagram. It's either a bar chart or a pie chart that they ask you to draw up. So it's quite straightforward. You also know more or less how to draw those up. There is also information in your slides when you go through them. When you have a chance to go through your slides, you will see exactly what you need, how to draw up the bar chart, how to draw up the pie chart. It tells you the steps involved in case you've forgotten. It jogs your memory in terms of steps involved, and then how to actually draw it up as well. So I'm just going to explain that again in a bit, in a second. But just to reiterate that these are the questions that could potentially come out of this learning unit. So not the entire learning unit is asked in an exam or your assignment 2. You will either choose between the grouped or the ungrouped section. So it's quite nice, it's quite beneficial. You're able to be quite well, you'll look at which you're more comfortable with, but naturally if it is the one that you're seeing on the screen, which you have most likely come across before, you're more confident in it, you're able to get a higher mark for something like this. And it obviously is a safer option compared to the group data section, which you will see in next week's session is a little bit more work involved. As I said, there are specific formulas. It's not as general as this content is for ungrouped data. So you might have a little bit of a tougher time with that one, but obviously we'll still go through that and you can look at it, suss it out, look at what you feel more comfortable with. If you're good to take on the challenge, then you are definitely going to be choosing that one in your assignment 2 and your exam. No, so as I had mentioned, I did speak about this in the first session, Izzy, and I also just mentioned it just now that obviously because you do have the choice between the section ungrouped data and group data in Learning Unit 3, you're able to obviously eliminate whichever one you do not want to attempt. So you are able to then not study that section for the exam because it is a choice between the two. It's generally section B of the exam. And this is also something I will explain in more detail closer to your exam date in your NSS session when I'll take you through the structure of your exam. We look at exactly which learning units are in each section, which are compulsory, which are optional, and like that, you'll be able to eliminate certain sections which are not necessary. So it really does bring your study load a lot less. It makes it a lot less than it initially would have been. Okay, so let's get started with this. So Learning Unit 3, your ungrouped data, the first part for today. Again, as I said to you, there's two approaches to your grouped data and your ungrouped data. So the first approach is your graphical approach, which, as I said, is where you are going to be drawing up either a bar chart or a pie chart. So the graphical approach to diagrams can possibly be asked. And both of these are explained in quite a bit of detail in your slides for Learning Unit 3. So please can I ask that you do have a look at that. It explains to you exactly what's required step by step with diagrams included and explanations wherever there's tables necessary. It has everything available to you indicating how it's drawn up. So you can read through that to jog your memory in case you've forgotten. I'm not going to go through the diagram, but what I do want to point out to you is the mark allocation when you are drawing these up. I will also go through it again in your second NSS session because that would obviously be closer to your due date for the assignment. So I will go through it then again, but just for now, in terms of the mark allocation, whenever you're drawing up a pie chart or a bar chart, you will, for example, let's just say it's a bar chart, you will always have a title at the top. There's a mark allocated to that. Then you need to have an axis label for your y-axis. So there's a mark allocated to that. Your x-axis also needs a label, so a mark allocated to that. Then when you draw up your bars, please make sure to write out the numbers on the bars. So let's just say this was a value of 8. Okay, let's say 10. So if you have a value of 10, you need to make sure that you write down the value 10 at the top. There's a mark allocated to that as well. And then there is a mark allocated to ensuring that between the bars of a bar chart, there are spaces. So just write out random figures here. So a bar chart will always have spaces between the bars, and this is where your marks come from. So heading for the bar chart itself, your X and Y axis need labels, then your values on top of the bars, and then the spaces between the bars. So just pointing out to you so that you know closer to your assignment 2 what will be required when drawing up a bar chart or pie chart. And then the same goes for a pie chart. You need to have a heading for it. It doesn't have to be a perfect pie chart. It doesn't have to be perfectly drawn and accurate with the values and the slices of the pie and so on, but it obviously does need to look like it makes sense. So naturally, if you're showing something that's about 10 degrees, you're not going to show a big portion like this because that would obviously be about a 90-degree angle. So here, try to keep it as accurate as possible. So if you're indicating about 10 degrees, then you are going to maybe, so the most sensible thing to do would be to split up the pie chart into four, and maybe do this in pencil if you're drawing it up freehand. If you are drawing it up on Word or Excel, then you shouldn't have a problem with that because obviously it will be as accurate as possible since you'll be inputting the data. But if you're drawing it up freehand, then maybe draw this line in pencil and then you're able to say that each portion here is 90 degrees. So if you're doing about 10 degrees, it should be about this much. So you'll obviously put in the relevant information here. There's a mark allocated for the information in each segment or each slice of that pie chart. There is a mark allocated to, generally we try to either have a key on the right hand side with maybe the color that you are drawing or you're filling in that piece with. So let's just say that's blue, and then maybe you can do the next color in purple or light pink and so on. So you can either have a key or you can just shade in the specific piece of that pie chart or slice of that pie chart in the respective color, and then also write the heading as well as the count or the frequency as well. So your marks come from the heading itself for the title of each piece together with its count, and then obviously for accuracy in terms of, as I said, it doesn't need to be like a perfectly drawn one, but obviously it needs to make sense in the sense that, as I said, if you're showing 10 degrees, it's obviously not going to be about a portion that looks this big. So you're not going to draw this and say that that was your 10 degrees or whatever number, whatever frequency it is. It obviously wouldn't make sense. So it doesn't need to be perfectly drawn, but obviously it needs to look like it makes sense that that was the respective category with a lower value if it's a 10-degree amount. Okay, so that's your graphical approach. Again, please make sure that you go through the content in your slides. And then the second approach is now the mathematical approach, which is what we are looking at here. So with your mathematical approach, we are actually calculating a whole lot of descriptive statistics. So descriptive statistics, remember, is where you are taking your data and you are condensing it into more meaningful measures. Meaning, if you look at the data set as is, it's not really telling you much. If you look at what they say to you here, they say that the following data set indicates the number of trips that a person makes to the local store over a period of 10 years. Now, as it stands, that information is just telling you the number of trips that a person has made to the store. So you want to be able to gather more information from this, meaning You want to break down that information and gather more info that can help you in decision making, such as the mean and the median and the mode and so on. So you want to know that if this was a number of trips over 10 years, what was the average number of trips over the 10-year period? Or what was the most common number of trips over that 10-year period, and so on. So you are taking your data and making it more meaningful by applying statistical measures to it, and then you're calculating the values that you see up on the screen. So these are the most commonly asked ones. They're actually all of the ones for this particular learning unit. There is one that is missing that I'm going to add on. So I'll add it on at the end, or whenever we are working with something similar, I'll add it on. But in total, there is about 13 calculations for this learning unit for section 1, or the first section, which is your ungrouped data. So any of the 13 questions can be asked. They are not all asked at the same time. So in a typical question, whether it's in your assignment or whether it's in your exam, they could ask you, for example, the mean, the median, the mode, the standard deviation, the coefficient of variance. And then they also ask you a graphical approach. So they'd ask you a couple of these, maybe about 5 of them, or maybe about 6 of them they would ask you. And then together with that, they would ask you to either draw up your pie chart or your bar chart. So this is the typical way that they ask you these questions. If you've had a look at assignment 1, you would have seen that already as well. So definitely not all 13 at once, but obviously any mix of them is possible. So we're going to go through all of these questions today. So let's look at it. And if you look at the values, they said to you that this was for a period of 10 years. So naturally, then when you count up all of these values, it does tell you that this would be a even number of these values. It does tell you that this would be a even number of values. And I chose this one because this is the one that requires a little bit more work to be done. So in your slides, you will see that there are examples where there's an odd number of values in your data set. So here, maybe instead of your sample size, instead of your number of values being equal to an odd number of values like 10, it would be 9. So when it's 9, when it's an odd number, then it's much easier. It's very straightforward. There's no calculations for most of them that need to be done. It's more about identifying what the figure is. So when there's an odd number of values, you will see that it's quite a straightforward process. You can refer to your slides for examples of these where it's straightforward. I chose to do an example where there is an even number of values in your data set so that I can show you how you would need to execute these calculations where there's a little bit more work that needs to be done. It's not as simple as just looking at the information and identifying which value you are looking for a particular calculation or for a particular question. Okay, so N is your sample size as always. This is something that we discussed in the first lecture. I mentioned it to you when we were going through some of your information about the module as a whole. So this is N, it is your sample size, meaning it's the number of values in your data set. So I'm just going to write that here as well, the number of values in your data set. And in this particular data set, as I said, if you count the values, it will tell you that N is equal to 10. So there are 10 values in total. And the first thing that we generally do, you don't have to do it first. You can do it when you get to the question for your median. But it's just easier to have it done from the get-go because it will be easier for you when you get to questions that actually require it, then you have it readily available. So what I'm referring to is rearranging your values. So when you have a data set that has values randomly listed out for you, the first thing that you would do is rearrange them so that they are in ascending order. So here in ascending order, you will have, and I'm just going to rewrite it at the top of this, you would have 41, then 88, 97, 109, 127, 142, 144, 165, 183, and the last one would be 199. Now, sometimes you might get lucky where they will already have it rearranged for you. So you won't have to rearrange it. It will already be in ascending order. And then sometimes you will need to rearrange it and there'll be a mark allocated to it specifically. Most of the time when you rearrange it yourself, there is a mark allocated to that. So you will literally get a mark just for writing this. Just for taking your values and placing them in ascending order, there will be a mark for that, which is easy, free marks that you really don't want to lose out on. So that's the first thing we're going to do before even getting to those calculations. So rearrange them, put them into ascending order because a lot of the calculations do actually require it in ascending order. So it just makes it easier to have it like that from the beginning. So the first calculation then is your mean. So your mean is calculated as the sum of all of your values. So each value is referred to as an X value. So an X value refers to each individual value. So it's basically saying the sum of all of your X values. This is the actual formula for it, over n, meaning just sum up all of your values and divide it by n. Now, we already said that n is equal to 10, so I'm going to rewrite that at the top here. So when you add up all these values, the 41 plus the 88, 97, 109, and so on, it gives you a total of 1,295, and that's divided by n, which is 10, and that gives you a mean of 129.5. So that's your mean, as straightforward as that, which I'm sure you're loving because it's quite easy, nothing complicated here. It possibly will all be coming back to you right now as you're looking at this. So hopefully it's something that you will feel more comfortable with as we go along. And then a lot of the time, you are required to interpret these as well. And I'm sure if you've had a look at your assignment again, you would have seen this, that for the section, you will be asked the question, you'll be asked to calculate a measure and then to interpret it. So for example, this would say to you then, since it was looking at the number of trips that a person makes to the local store over a period of 10 years, all you're going to say is that on average, so I'm just going to write it at the bottom here, on average, a person makes 129.5 trips to the local store. Or you can say made. So instead of makes, you can say made. So I'm just going to write it at the top. So made 129.5 trips to the local store. And then you can include, when you say made, then you can say over the past 10 years. So whichever you prefer. We're not hard and fast with the wording of something like this. There are certain ones where you will have to stick to a particular wording or you'll have to include a specific word here and there. But when it comes to your average, your mean interpretation, As long as you're saying that on average, this is the number of blah, 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 or this is how many blah, 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 then you're perfectly fine. So here, on average, a person makes 129.5 trips to the local store. You can stop there if you'd like, if you're saying it in that way. But if you really want to go further, you can just say, on average, a person made 129.5 trips to the local store over the past 10 years. Okay, and that's your mean done. The next one then is your median. So for your median, there are 3 steps that needs to be followed. Now, what I need to stress for this learning unit is that although you are familiar with these questions, you most likely will be, and you have your own methods of calculating some of these or the steps that you follow to get to the answer and so on, please do not use your own methods. Please stick to the methods that I'm teaching you, the methods that are in your slides, because the IIE memos are according to these methods. So if you're using your own method to get to a calculation, if a question's out of 5, for example, you'll get the mark for the final answer, but for the method itself, for the actual lead up to that answer, you're not going to get the marks. So out of a question that's about 5 marks, you're going to get 1 out of 5. So please make sure to not do your own methods for any of these calculations unless they are exactly the same as the ones that I'm showing you. Rather stick to the ones I'm showing you and the ones that are in your slides as well. Okay, so the reason that I was pointing that out is because for the next one, which is your median, there is also, as I said, 3 steps that need to be followed. So I'm just going to erase, excuse me, I'm just going to erase here. I will write down that mean value again, just next to it to indicate that the mean was 129.5. So we're done with that. Currently working on the median. Sorry, I just want to have a look at the questions in the chat. Akani, no, so that is not an optional question. It is part of the question itself. So, for example, if you're choosing the question based on ungrouped data, you'll always have a couple of calculations, like I said, any 5 or 6 of these ones. And then over and above that, in addition to that, you will have either the bar chart or the pie chart that you will have to draw. So all of this, all 5 or 6 questions and the bar chart or pie chart, you will have to draw. So all of this, all 5 or 6 questions and the bar chart or pie chart would be compulsory if you're choosing ungrouped data. If you're not choosing ungrouped data, then the alternative is 5 or 6 questions from the next page. So from here, 5 to 6 questions from here. And then there's also something that will need to be drawn up here. It's either a table or it is a specific graph that's drawn up here, but we'll obviously look at that next week. But there is always either a table or a graph that needs to be drawn up under each section. So there's no getting away from that because both grouped and ungrouped will have a graphical approach. Okay, and then they will give you both, they will give you which one you need to do. So you're not going to either be able to draw a bar chart or a pie chart. They will specifically say to you in that question, draw up a bar chart based on this information or draw up a pie chart based on this information. So there's not a choice between which diagram you're drawing up either. Okay, so back to this question, your mean. So with your mean, you have, as I said, 3 steps that needs to be followed. So the first step for your median is to rearrange your values. Now, we've already done that in this question, so we don't need to worry about step 1. Step 2 then is to determine the position of your median. Now, when it comes to ungrouped data, which is what we're doing today, the formula for the position is n plus 1 over 2. This is for your median. So in this case, n is 10. So it would be 10 plus 1 over 2, and that would be 5.55. So this is not the actual value of the median. This is just telling you where the median lies. Please remember that, because a lot of people make a mistake and they calculate this position and they just say that that's the median. So they would say 5.5 is the median, which is not correct, because that's just the position of the median. So please make note that there is a step after determining the position, which is now saying to you, if it's 5.5, it's saying take the fifth value in your data set, add on the sixth value, so fifth value plus the next value, and divide those by 2. So in your data set, the fifth value from the rearranged values, that would be 127, and the sixth value is next to that, which is 142. So 127 plus 142, and you'll add those, divide by 2, and that is 134.5. And that would be your median. And now you will also sometimes be asked to interpret here. And to interpret your median, you are going to say that since it's your middlemost number, meaning it separates the first or the lower 50% of your data from the upper 50% of your data, you will say then that 50% of the time 134 or a person makes, let me rather say that. So a person makes 134.5 trips or less to the store. Okay, so you will always interpret it in this way. I'm going to highlight for you what changes from interpretation to interpretation, but the rest of it will stay the same. So you'll always say 50% of the time or half of the time. And obviously in this case, because it was based on a person's trips to the local store, that's what will change, because it obviously will not always be based on information where a person made a trip to the store. So that will change, and this will change. So only the parts that I've highlighted in blue is what will change from interpretation to interpretation. The part that I did not highlight is a standard, you could say, template for your interpretation. You'll always say 50% of the time or half of the time. This is whatever the value or whatever you're looking at. Let's just say it was the number of times that you had looked at your module on VC Learn. So you would say 50% of the time, for instance, a person logged onto their stats module 134.5 times or less. And this is what's important. It's always or less. It is never or more. So in your interpretations, just always stick to saying that. You can say or more, but as I said, the IIE does require as a norm certain explanations and interpretations. So please do stick to this. So whatever is not highlighted here will stay the same. Whatever's highlighted in that interpretation can differ from example to example. So that's your interpretation for the median. Yes, so if you skip the position, generally a question for the median is worth 5 marks. So the or 4 marks most of the time, actually, not 5. So if you are skipping the step of the position, I'll tell you where your marks come from. There's 2 marks for the position, 1 mark for the final answer, and 1 mark for the interpretation. So you're actually losing out on 2 marks for absolutely no reason if you are not showing the position. So please make sure to show the position. If it's a question worth 5 marks, then the additional mark comes in from showing the working out first and then the final answer. So sometimes when you do have to do a bit more work, then it will be a higher mark allocation. But just for the position, to calculate that, it's generally 2 marks, which again, you do not want to lose out on unnecessarily. No. So there is literally, as I pointed out here, a tick is next to it, indicating that there is a mark for showing that formula. So again, you'll lose 1 mark then if you just show the value of the position and not the formula. Okay, so let's move on to the mode then. Yes, unfortunately, it is a bit hectic, and because we have to mark so strictly against the memo, we do unfortunately have to insist that you do certain parts that they require in these memos. So obviously, it is something that we could look past if it was just us. But unfortunately, because the memos come from the IIE and because it is moderated, your exams, it obviously is not something that you want to take lightly, because even if I did give you the mark for it in the exam, once it's moderated by an external moderator, they will remove the mark anyway. So you really don't want to face that unnecessarily. Okay, so the next one was your mode. So the mode is straightforward. It is just the most frequently occurring value in your data set. So with your mode, you're looking for the number that just appears more than once. So it is possible that you will have no mode. And in this example, there is actually no mode. And all you need to do is just write down that there is no mode. Okay, so that's question 3. So we're done with that one. You'll just state that there is no mode. Okay, so the next one that is up is your first quartile. And your first quartile, and this is why I've actually left the information on the side here, it follows the same steps, both your first quartile and your third quartile. It follows the same steps as your median. So we're looking at the first quartile and then the third quartile. And I'm also going to, remember at the beginning, I said to you there is one other one that is not listed out here, but I'm going to add it in. So once we're done with the third quartile, I'll add it in. So the first step is again to rearrange your values. But obviously, if that's done already, you don't need to worry about it. There won't be another mark allocated to it. There would be a mark at the beginning for rearranging generally. But obviously, if you are having to rearrange more than once, it's a duplication of mark. So you're not going to get a mark every time you needed to rearrange. So that's your first step. The next step is your position. So for your position, for a quartile 1, Q1, remember it's also called Q1. So I'm just going to write that next to it, that this is so-called Q1. So I'm just going to write that next to it, that this is Q1. I'm also just going to write that for your median, we had calculated it to be 134.5. Sorry, when I'm erasing, it's all coming out. So let me rewrite that. That was 129.5, 134.5, and there was no mode. Okay, so we're on the first quartile. As I said, this is known as Q1 as well. So remember, quartiles split your data set into 4 equal parts. Now, we only look at Q1 and Q3. Again, please make sure that you go through the content of the learning unit, the slides that I've made available on VC Learn under your more resources lecture slides. It's very, very important that you read through the slides, because remember, I am doing the practical approach in these live collab sessions where I take you through typical exam assignment questions. you need to do the back work in terms of going through the content, reading through it, identifying any of the symbols or concepts that you will come across in the learning unit. So please make sure to read through the content as well. So this is the position that we're at the moment. And for the first quartile, it's calculated as n plus 1 over 4 this time, because you're splitting your data set into 4 equal parts. So here again, n is 10, so 10 plus 1 over 4, that gives you a position of 2.75. So again, this is only the position. So it's saying to you that the 2.75th value in your data set is your Q1, but now you need to determine what the 2.75th value is. So that's what we're doing in step 3. Now here, and please pay careful attention to this, because you are going to possibly be seeing this for the first time. So you do need to pay attention to how it's calculated. The first thing you're going to do is go back to the position. Take the first number, which in this case is the 2. The 2 is saying to you, go to your data set and identify the second value. So in line with the number 2, it would indicate the second value. So the second value in your data set is 88. So you're going to write down 88. And then to this, you're going to say plus and put together 2 square brackets. And then within the bracket, you're going to work out first the difference between that 88 and the number after it. So from the numbers, again, always the one that's in ascending order, the number after 88 is the 97 here. So work out the difference between that 97 and the 88. So you're going to say 97 minus 88. And that difference is multiplied by, remember from the position here, you only looked at the 2 first. The 0.75 that we ignored at the beginning, this is what you now multiply by. So I'm going to say that one again, just in case you got confused anywhere, or you just needed one more round of it to be clear. So from the position of 2.75, I'll write that down at the top again. So 2.75 is your position. The 2 says to you, go to the second value in your data set. So the second value, as we said, was the 88. So I'm just going to write it here again. Then it says add on 2 square brackets so that you can write within them. The first thing you're going to do is work out the difference between that 88 that you just wrote down and the number after it from the data set. So the number after it, we said, was the number 97. So it's 97 minus the 88. And then you take whatever decimal you had left from the position that you didn't worry about at the beginning, you multiply it by that decimal. Okay, so this is something that you possibly have not seen before. Again, naturally, you might have your own ways of calculating these, but please stick to this method that I have shown you here. I'm just going to erase the one at the top because I do have it written at the bottom as well. So here, this would give you an answer of 94.75. So your Q1 is 94.75. And now to interpret it, Q1 is representing the lower or the first 25% of your data set. So you're going to say 25% of the time, or you can say a quarter of the time in place of that. So either 25% of the time or a quarter of the time, a person makes 94.75 trips or less. Remember, that stays as is, to the local store. So again, if you look at that, the only thing that changed was that a person makes so many trips and then it's to the local store. And then here, because it is the first quartile, we said 25.75, 25% of the time, a person makes 94.75 trips or less to the local store. So in place of 25% of the time, you can say a quarter of the time. That's perfectly fine as well. And that is your calculation of your Q1. Okay, then you have your Q3. So same steps involved in your Q3. The first step is to rearrange your values, but again, we have already done this, so we're not going to worry about that. The next bit says to you to calculate the position. So for your position, sorry, I'm just erasing here so we can write down this answer. Okay, so the second step is your position, and the position for your third quartile is calculated as 3 multiplied by n plus 1 over 4. Now, it's very easy here to get that formula wrong because a common mistake is that people attach the n to the 3. So instead of saying 3 multiplied by n plus 1, which is in brackets. Remember that n plus 1 is in brackets. They just write it as 3n plus 1, which is not the correct answer because in this way you're attaching the n to the 3, which is not supposed to be done. The n plus 1 is within brackets and then the 3 is on the outside. You will literally get different answers here if you do that. So please make sure to not do that. Please make sure to leave the n plus 1 within brackets and the 3 on the outside. So that's your position, 3 multiplied by 10 plus 1. So 10 plus 1 is 11 times 3, which is 33 divided by 4. And that tells you that the position for your third quartile is 8.25. So the 8.25th value is your Q3. Now let's calculate it. So to calculate Q3, you are going to do it in exactly the same way that I showed you just now. You're going to say, separate the first number, which is 8, from the second part of it. So 8 is saying to you, go to the 8 number in your data set. So the 8th number in your data set is 165. So you're going to say 165 plus. Then you're going to put in those square brackets and you're going to work out the difference between 165 and the number after it. So it's 183 minus 165 and you're multiplying that by the difference in that position that you did not initially worry about. So times 0.25. And like that, you are done. So this gives you 169.5. So in terms of your interpretation, you will say, since this is the third quartile, this is showing you 75% of your data. So 75% of the time, a person makes 169.5 trips or less to the local store. Okay, so that's your calculation of your third quartile as well as your interpretation of it. All right, so that is Q3, which is also known as your third quartile. So I'm just writing it on the left-hand side so you're familiar with that. So that's your third quartile. Let's look at the next one, which is now your interquartile range. So this is quite straightforward, but only if you had Q1 and Q3 already calculated. Now, why I'm saying that is because sometimes they might actually not give you that figure, the Q3 and the Q1 calculated. So you will need to now go back and start from scratch. So here, your interquartile range is calculated as Q3 minus Q1. So I'm just going to remove the things on the side here so we have a little bit of space to work with. Okay, so here you have your interquartile range. So Q3 minus Q1. Now I'm just going to write down what Q3 and Q1 were. So Q3 was 94.75. And we just did Q1, which was 169.5. So again, as I said, a lot of the time it's quite easy. All you're doing is taking the Q3 figure, which was 169.5, and you're subtracting Q1, which was 94.75. So that gives you a figure for your interquartile range of 74.75. Okay, so that's your interquartile range. And then your quartile deviation, number 7, is just a build up from this calculation. The quartile deviation, it's denoted by the letters QD. It's just your interquartile range divided by 2. So here it's the 74.75 that you had calculated as your IQR, and that's divided by 2. And here your answer is 37.38. Okay, so before we move on to the next one, so this was your interquartile range, 74.75. This was your quartile deviation, 37.38. Now I'm going to include one more here. So maybe you can put it in, 37.38. Now I'm going to include one more here. So maybe you can put it in as number 6 under number 5. Make that 7, make that 8, make that 9, 10, 11, 12, 13. So I was saying earlier that there are about 13 calculations here. So I'm going to include as number 6 here. There is a number 6 and a number 7, but we're going to make it 7 and 8. So this will become 7, 8, and then we're doing number 6 now. So I'm going to randomly pick a number. Let's just say 59. So it'll say the 59th quartile. Oh, sorry, 59th percentile. Sorry, I'm just writing the wrong word here. Okay, so the 59th percentile. Now, what do we mean by this? So let me just highlight that. Okay, so what do we mean by this? The, sorry, it came out. It is the 59th percentile. It's actually done in the same way that the other two calculations before this were done, meaning it is still calculating the position. Sorry, it's still rearranging first. And then once you have rearranged, you determine the position. And then once you have the position, the last step is to calculate the figure itself. So again, I'm just going to erase all of this. And what I'll do is I'll write down the figures next to it. So your interquartile range, that is number 7. This is 74.75. And then your quartile deviation was 37.38. Okay, so first step, determine your, rearrange your value. Second step, your position. And then third step is to actually calculate your percentile. So you've done step 1, rearrange the values. Step 2 is to calculate the position. It's calculated as P multiplied by N plus 1. So here, P is whatever percentile they asked you. In this case, it was 59. Make it a decimal. So instead of 59, it's going to be 0.59. And then this is multiplied by 10 plus 1. So that's 11. So here you're going to say 0.59 times 11, and that would be 6.49. So the 6.49th value in your data set is your 59th percentile. So now you're going to again separate that. For your numerator, you're going to say it is, sorry, not for your numerator, for the first part of it, it is 6, saying to you, take the 6th value in your data set. So here, your 6th value is 142. So that's 1, 2, 3, 4, 5, 6. Yes, 142. So you're going to say 142 plus. So that's here, 142. Then you're going to now put in your square brackets. The first thing you're going to do is work out the difference between 142 and the number after it, which is 144. So 144 minus 142. And then you're going to multiply this by the amount from the percentage that was, from the position that was left out. So this 0.49 here in your position, this 0.49, that's what you're going to multiply by here. So it's 142 plus, then you have the difference between your value after that value, your value you selected. So the value after 142 was 144, and then you worked out the difference between them and you multiply that by the remaining portion of your position that you just left at the beginning. You just left it out at the beginning, so times 0.49. So this gives you an answer. Sorry, for some reason it's not allowing me to write. Okay, there we go. So this gives you a value of 142.98. Okay, so that's how you calculate your percentile. It's almost identical to the median and the first quartile and the third quartile. Very little difference between them. And this is simply the steps of rearrange the values, determine the position of your, whether it's the median, whether it's the quartiles, whether it's the percentiles, you determine the position. There's different formulas that's used. Because it is a quartile calculation, it's n plus 1 over 4. And then the next one is to actually calculate the present value. Okay, so your answer here is 142.98. So please make sure you're taking that down because I didn't have an example of it up on the screen. So it would be quite beneficial to write down the 3 steps that I had followed here. Okay, then the next question is your range. So here your range, there's it here. Your range is quite straightforward. It's your highest number in your data set minus your lowest number. So I'm just writing the answer to this here on the left-hand side. Your highest number in your data set is 199 minus the lowest number is 41. So here, you don't need to rewrite any of the formulas. There's no marks allocated to it. This would give you 158. Okay, so that's number 9 done as well. Then you have the variance. Now, the variance, you again need to follow a specific formula. Again, I know that you possibly have come across one previously, but there is a general rule when it comes to this calculation. So I'm just going to erase this here. Okay, so your variance, this is the formula that you're using. It's a sum of x squared minus n times your mean squared over n minus 1. Okay, so now let's look at how we need to break this down and how we are, or where we're getting the figures from. Sorry, I just want to... yes, there's no interpretation for your interquartile range and your quartile deviation. In fact, I don't think any of them except the last one here has any interpretations then. Sure, not a problem. It's just 4 more calculations and we'll be done, so that's no problem at all. Okay, so now let's look at, as I said, what we have versus what we don't have. So I'm just going to take out the values from the bottom here, so I have some space, and then we can, I'll write down the answers for whatever I erased. I think it was just the range, so that was the 158. Okay, so from the formula for your variance, if you look at the sum of x squared in the first part, we don't have that. We do have n. We know that n is equal to 10. So what I'm going to do is I'm going to start writing out the formula and plug in the value. N, we know that n is equal to 10. So what I'm going to do is I'm going to start writing out the formula and plug in the values that we do have. So you have minus n, which is 10 here, and then you have 10 minus 1 in your denominator. Then you have the sum, sorry, I wrote down the wrong figure here. I'm thinking about the next learning unit. Okay, so within bracket, you have your mean squared. Okay, so you have your mean. It was already calculated in question 1. So you do not need to calculate that again. Your mean is 129.5. So you will take that mean and you will plug it in here and then that's squared. So essentially the only thing that we don't have here is the sum of x squared. Now, what is the sum of x squared? Remember I said to you at the beginning, and it's still written here, that each value is referred to as an x value. So that means we're squaring each value and we're summing it up, meaning you're taking the first value, the 41, and you're saying squared plus the next value is 88. So 88 squared plus the next value is 97, and then squared plus the next one is 109 squared, 127 squared, and you'll continue like that till the end. So when you add those up, that gives you the sum of x squared, which in this case is 188,059. So that becomes your numerator here, 188,059. And then when you put this entire bit into your calculators, the 188 and 188,059 minus 10 times your mean of 129.5 squared over 10 minus 1, that would give you 2,261.83. As a general rule, and this is something that I said to you last week as well, and in the introductory session, that you will always stick to two decimals unless they state otherwise. Most of the time, because this is a default, this is a standard rule when it comes to your rounding up of your answers, it will always be a two decimal place answer, no matter what. Unless the next number is 0, then you don't have to worry about that. Like if it's 129.50, then you can just leave it as 129.5. You don't have to actually put the 0. But other than that, it will always be two decimals. Okay, so then you have your variance. That's done, number 10. Then it is that was your mean in question 1. So remember, in the formula, if you look at it here, this within the bracket is symbolizing your mean. X bar means your mean. So this is just a symbol that is used to denote the mean. I'll write it next to it here. That is your mean. So that was already calculated. You didn't need to calculate it again. Then number 11 now is your... No problem. So I'm going to just write down that answer next to it. So that is 2,261.83. Then the next one is your standard deviation. So this is a really easy one as well. The standard deviation is simply the square root of your variance. So in this example, we already calculated your variance to be the 2,261.83. So it's a square root of that, and that would give you 47.56. And that's your standard deviation done. Then the next one is your coefficient of variation. So your coefficient of variation is calculated as the standard deviation. I'll write it here, coefficient of variation. It's your standard deviation over your mean, which is X bar, times 100. So this is expressed as a percentage, which is why we are multiplying by 100. And most of the time here, you will have both the answers already. Like the previous one, when we were doing the variance, you already had the mean calculated in question 1. So it's the same thing here. Most of the time, these questions that require another answer from another question, they're given later on. So you would have done the answer earlier on for something, and you just need to pull through the figure for this calculation. So here, your standard deviation, which you just did now, is 47.56. And then your mean from question 1 is 129.5. That's multiplied by 100, and that's 36.73%. Okay, so that's question 12, and then question 13. Remember, it is question 12 here, but because I added on the 59th percentile, we had one more question. So it went up to 13 instead of 12. Okay, so the last one is calculate the coefficient of skewness. It's called Pearson. Actually, the letter A is missing there. It should say PEA. So it would be, this is what it's called. Let me write it down at the top here. Okay, so it's actually called Pearson's. Sorry, somehow the N got removed here. I just want to see if it's on the next page also. Okay, so here's the correct word at the bottom here. If you look at it, the last one, Pearson's coefficient of skewness. So I'll just write it down here again. So Pearson's coefficient of skewness. So this coefficient of skewness. So this coefficient of skewness also has a specific formula that needs to be calculated. So it's calculated as 3 multiplied by your mean within brackets minus your median over your standard deviation. So again here, this is one of those questions that requires answers that were already done for you. So I'm just going to erase here so I can write down the answer. Okay, so you're going to say it's 3 multiplied by your mean was in question 1, the 129.5. Your median in question 2, the 134.5. And your standard deviation, which you did at the bottom here, is 47.56. So this gives you an answer of minus 0.32. And they do ask you to comment for this question. So I'm going to tell you what the comment will be, but it's also in your slides. So there's a general rule in terms of commenting for Pearson's coefficient of skewness. If you get an answer that is equal to 0, this means that you have a symmetrical distribution. So all you'll say is that there is a symmetrical distribution. If you have an answer that's greater than 0, you will say that the data or the data set is positively skewed. And then literally the opposite, if you get a value that's less than 0, you will say that the data set is negatively skewed. So in this case, you have a negative value for your coefficient. So you will say that therefore this data set is negatively skewed. Okay, so that's it for today and for your ungrouped data. Please, can I ask again that you go back to your slides? There are more examples within the slides, just helping you to get this better, to understand this better. They are mostly all worked out for you already. So they have solutions, they have the whole method for you, explaining every step in detail. So please, can I ask that you go through those slides as well? And then I will see you again next week when we will go through your grouped data section. I will also make this worksheet available on VC Learn, and I will also upload this recording to YouTube. I'll let you know when I have uploaded it. Thank you, everyone. Is there any questions? Are there any questions from anyone? Perfect. Thank you, everyone. Enjoy the rest of your evening and the rest of your week, and I will see you again next week. Cheers, everyone.